Hey guys, in this video, we will be using Geogebra to understand how integration works by approximating the area under the curve by using many small rectangles. We will start by graphing a cubic function. We will use the function f of x equals to x cubed plus 4x squared plus 7. Integration is the process of getting the area under a curve by using limits or boundaries. Now we will use the function upper sum. This function allows you to choose two x coordinates, and these two x coordinates will be the boundaries of the area under the curve that we are finding. We will use the points -1 and 0. Now we will input the function upper sum. And as you can see, the application will show you the rest of the function. Click on it, then you write the function as f. The start value of x is -1. And the end value is 0. And the number of rectangles we will leave as a random letter such as C. This will allow us to adjust the number of rectangles later on. As you can see, a slider will appear. This slider allows you to change the number of rectangles under the curve. As you can see right now, there's one rectangle from -1 to 0. But let's change the slider settings. Let's make the minimum value 1. And the maximum value 100. No, actually let's use 1000. The increment doesn't really matter because the application will round off the number of rectangles if it's a decimal. Alright. Oh, wait. Alright, so now you can adjust the number of rectangles. By increasing the numerical value of the slider, the area will then get closer and closer to the actual area. As you can see right now, there's one rectangle, and there's a large portion of the rectangle is above the curve, so this does not really give an exact value for the area. But as we increase it to 78, or no, that's quite large. Let's leave it at 4. As you can see, there are still some the rectangles are still protruding above the curve, but the area is more exact than before. And now let's increase it to 252. And yeah, from here it looks as though it's the exact area, right? You don't really see many rectangles protruding, but if we zoom in, you will be able to see that all the rectangles are still slightly protruding above the curve. Even if we increase it to the maximum value that we have here, which is 1000, there will still be some portion of the rectangle that protrudes above the curve. In conclusion, we can approximate the area under the curve using this method, but this will still not be the exact area under the curve. To check the actual exact area, we will use the integral function in Geogebra. We type in integral, then the function f, the start value of -1 and the end value of 0, and as you can see the area is 8.08, right, which is it's the same as the area from the upper sum function, but in reality the actual exact area is 8.083333 and so on if you calculate it on a calculator, but GeoGebra just rounds it off to 2 decimal places, so that's why it looks the same, but it's actually not. This is why in reality, when we're solving problems relating to areas under curve, we have to use the integral function of the curve, which will allow you to get the area of an infinite number of rectangles under the curve. So using the integral function will give you the exact area under the curve, but using the method shown in this video of making many rectangles that fit under the curve and finding the total area of those rectangles will not really give you an exact value and will only give you an approximation. Alright, that's the end of the video. Thanks for watching. Hope you enjoyed.